You probably think the Earth ends in fire, or ice, or an asteroid, something dramatic, something with a countdown. Most of the ways this planet actually ends are quieter than that, and several of them are already underway. I've sorted every credible way the Earth could end into 8 tiers, from the ones that merely knock civilization over to the one that erases the planet from existence entirely. Each tier is more final than the last, and I'm going to tell you which are survivable, which are guaranteed, and roughly when. The last one on this list is certain. It has a date, and nothing anyone will ever build can stop it. Let's start small. Tier 1. The events that end civilization, but not the planet. A solar flare sounds harmless? It is not. In 1859, the sun fired a coronal mass ejection directly at Earth in what's now called the Carrington event. Telegraph lines sparked. Operators got shocks. Some telegraph systems kept transmitting after being disconnected from their batteries, running on current induced by the sky itself. That was in a world with almost no electrical infrastructure. A Carrington-class event today would induce currents in long conductors, power lines, pipelines, undersea cables. The vulnerable part is the large transformers at the heart of the grid. They are custom-built, they weigh hundreds of tons, and there is no warehouse of spares. Replacement is measured in months to years. Estimates of the odds of a Carrington-scale event in any given decade run in the low single-digit %. Over a human lifetime, that is not a small number. Then there's the supervolcano. Around 74,000 years ago, Toba in Sumatra erupted with a force that dwarfs anything in recorded history. It put enough sulfate into the stratosphere to cool the planet for years. There's a long-running hypothesis that this event drove human populations down to a bottleneck of a few thousand individuals. Genuinely debated, not settled, but the eruption itself is not in doubt. Yellowstone gets the headlines. The USGS puts the annual probability of a Yellowstone supereruption at roughly 1 in 730,000, and notes there's no indication of one being imminent. The real risk is that there were dozens of such systems worldwide, and we only monitor some of them closely. And the third in this tier is the one you have already lived through a smaller version of, a pandemic. The 1918 influenza killed somewhere between 50 and 100 million people in a world of under 2 billion, with no air travel. None of these end the Earth. They end the arrangement humans have made on top of it, which, for you, is arguably the same thing. Tier 2. Impact. 66 million years ago, an object roughly 10 to 15 kilometers across struck what is now the Yucatan Peninsula. The Chicxulub impact released energy in the range of 100 million megatons, orders of magnitude beyond the entire global nuclear arsenal, and ended roughly 3/4 of all species on Earth, including every non-avian dinosaur. The killing mechanism was not the impact. It was the dust and sulfate aerosol thrown into the stratosphere, which shut down photosynthesis. The food chain collapsed from the bottom. Here is the part that surprises people. This is the one item on the entire list we can currently do something about. In September 2022, NASA deliberately crashed a spacecraft into a small asteroid moon called Dimorphos to see whether a kinetic impact could change its orbit. It worked better than predicted. The orbital period shifted by about 32 minutes. The target had been a change of 73 seconds or more. That is a real demonstrated planetary defense capability, on the condition that we spot the object with years of warning. Surveys have found most of the kilometer-plus near-Earth asteroids. The smaller city killers are far less completely cataloged. So Tier 2 has an asterisk. Dangerous, historically proven, and uniquely on this list, partially solved. Tier 3, the ones we're doing to ourselves. There are roughly 12,000 nuclear warheads on Earth. The direct blast effects would be catastrophic and regional. The mechanism that would make it global is nuclear winter. Firestorms and burning cities lofting soot into the stratosphere where there is no rain to wash it out, dropping global temperatures and collapsing agriculture for years. The modeling here is genuinely contested. Soot injection estimates vary widely, and some researchers argue the severe scenarios overstated. But the physical mechanism is the same one that makes supervolcanoes and asteroid impacts lethal. Block the sun, break the food supply. Alongside that sits engineered biology. A natural pathogen faces an evolutionary trade-off. Kill too fast and you stop spreading. A designed one does not necessarily face that constraint. This is the risk category that has grown fastest because the cost of the underlying technology has fallen fastest. Notice the pattern across tiers 1 to 3. Almost nothing kills by direct violence. Nearly everything kills by blocking sunlight and breaking agriculture. If you wanted one sentence for how planets become uninhabitable, that's it.
Tier 4. Runaway climate. Earth has a neighbor that already did this. Venus is nearly the same size as Earth and receives about twice the sunlight, and its surface sits at about 465 degrees Celsius, hot enough to melt lead, and hotter than Mercury despite being further from the sun. The mechanism was a runaway greenhouse. Water evaporated. Water vapor is itself a greenhouse gas, which raised the temperature, which evaporated more water. The feedback ran to completion. Ultraviolet light broke the vapor apart high in the atmosphere, and the hydrogen escaped to space, so the water never came back. Now, the honest version. Current mainstream science does not consider a Venus-style runaway achievable on Earth by burning fossil fuels. Earth is further from the sun, and the threshold appears to be well above anything our carbon reserves can reach. Papers proposing a fossil fuel runaway are outliers. But the same physics does get Earth eventually, from a different cause, and that's the next tier.
Tier 5. The sun brightens and the oceans leave. The sun is not a constant. As it fuses hydrogen, its core contracts and heats, and its output slowly rises. It is roughly 30% brighter now than when Earth formed, and it will keep going. In about 1 billion years, the increase is projected to push Earth past the threshold Venus crossed. Oceans evaporate, water vapor dominates the atmosphere, hydrogen is lost to space permanently. Before that, something subtler and arguably sadder happens. Higher temperatures accelerate the weathering of silicate rock, which pulls carbon dioxide out of the atmosphere. Below a certain concentration, standard photosynthesis stops working. On timescales of a few 100 million years, most plant life becomes impossible, long before the oceans are gone. There is no scenario where humanity survives this in place. It is not an emergency. It's a deadline with 9 zeros on it.
Tier 6. The sun eats the inner solar system.
In about 5 billion years, the sun exhausts the hydrogen in its core, and the outer layers swell into a red giant. Its radius grows by a factor of more than 200. Mercury and Venus are certainly consumed. Earth is genuinely uncertain, and the uncertainty is interesting. As the sun expands, it also loses mass through an intensified solar wind, which weakens its gravitational grip and lets Earth's orbit widen. So there's a race between the expanding surface and the retreating orbit. Recent modeling mostly favors Earth being engulfed anyway, dragged in by tidal interaction with the sun's bloated outer envelope. But even in the version where Earth survives physically, it survives as a scorched, airless rock orbiting a dying star. The distinction is academic. After that, the sun sheds its outer layers and leaves a white dwarf, an Earth-sized ember that cools for trillions of years.
Tier 7. The galactic collision, which is the gentlest item on this list. The Andromeda Galaxy is approaching the Milky Way at around 110 kilometers per second, and the two are expected to interact in roughly 4 to 5 billion years. Everyone imagines catastrophe. The reality is almost comic. Galaxies are overwhelmingly empty. The typical separation between stars is millions of times their diameter. In a galactic collision, the odds of any two stars actually hitting are effectively zero. What actually happens is gravitational rearrangement. Orbits are stretched and flung. The two galaxies eventually merge into a single elliptical galaxy. The night sky would be extraordinary. The ground under your feet would not notice. Worth adding, recent Gaia-based analyses have downgraded this from certainty to roughly a coin flip over the next 10 billion years. Even the galactic collision is less dramatic than advertised. Tier 8. The end that has no survivors and no exceptions. Everything so far is local. This one is the universe itself. Current observations indicate the expansion of the universe is accelerating, driven by dark energy. If dark energy behaves as a cosmological constant, the universe expands forever and cools toward heat death. Stars burn out, matter disperses, and eventually, no process anywhere can extract useful energy. Nothing can happen. There is no version of surviving that. The timescale is beyond intuition, a Google years for the last black holes to evaporate. There is a more abrupt possibility. If dark energy strengthens over time, expansion could tear apart galaxies, then solar systems, then atoms in a big rip. Some analyses put that at tens of billions of years, though it is not the favored model. And there is the strangest one, vacuum decay. If our universe's vacuum is not in its lowest possible energy state, a bubble of true vacuum could nucleate somewhere and expand at the speed of light, rewriting physics inside it. You would receive no warning because the warning would arrive at the same instant as the bubble. Measurements of the Higgs boson and top quark mass put us intriguingly close to the boundary between stable and metastable. The estimated timescale is vastly longer than the current age of the universe, and one detail I find genuinely funny, this is the only entry on the list where you are guaranteed not to suffer, because there is no interval between fine and gone.
So here's the whole list, sorted. Solar flare, supervolcano, and pandemic end civilization, not the planet. An asteroid impact could do far worse, and is the only one we have already demonstrated a defense against. Nuclear winter and engineered pathogens are self-inflicted, and the only ones with a decision maker. Runaway greenhouse ends Earth's habitability in about 1 billion years. The red giant ends the planet in about 5 billion. The Andromeda collision, despite the branding, barely counts. And heat death ends the possibility of anything happening at all. 2 things stand out to me from putting it in this order. First, almost every near-term extinction mechanism works the same way. Put something in the stratosphere, block sunlight, break agriculture. Soot, dust, sulfate. Different causes, one killing mechanism. That's a genuinely useful thing to know because it means resilience against one buys you resilience against most. Second, and this is the part worth taking with you, exactly one item on this list has a proven countermeasure, and we built it in 2022 by hitting a rock in space and measuring how much it moved. Everything above Tier 2 is out of reach for now. Everything at Tier 3 is a choice, not a physical law. So the honest summary is that the Oath is going to end, on a schedule, and the only entries anyone alive can influence are the ones we would be doing to ourselves. Next time, I'm doing the opposite of this list. Every place in the solar system where life could actually still exist right now, including a moon with more liquid water than every ocean on Earth combined hidden under an ice shell. And the reason we haven't drilled into it yet is not technical. Subscribe, and I'll see you there.